All right, let's get started today. If you're joining the stream after the fact, or if you watched my last stream, you know that I worked a bunch on my line number program debugger, it's LNPDB, line number program debugger, which is used to debug the line number program interpreter that I have to use for the DWARF format. And so I spent a lot of time trying to figure out what was going wrong with a certain spot. And what I did end up doing is adding in a representation here of the actual assembly code that's being used. So when we hit the address, and I'll show this here just down a second. I'm gonna scroll down. Right here, we're at this instruction, and it sets an address. 0x11E9B10. You see that? 11E9B10. That is the address of the instruction. It's the push instruction. So I'm gonna say that the prologue should be set to true. Is statement prologue end. So when we get down to, let's see, push RBP, move RSP RBP, that is probably the end of the prologue. Yeah, because this function doesn't do much here. I don't know what function it is because there's a little bit of a bug that I have in the thing, but it's working right now. Now, the other bug that I'm having is I was able to solve the bug last time, which is, sorry, to be sure, where is it? It was in, what was it? Decode, advanced special opcode. I had forgotten to add this line change. And so the line number wasn't being changed all the time when it should have been changed. And that ended up getting me off on my line numbers. So that's good to know. What I'm going to do here is actually commit our changes before we move on. So let's add LNPDB. And let's look through these changes here. Let's see, git diff tool -y head. All right, so what we've got here is LNPDB. We made this change here, added a special opcode. Okay, so actually I want to make this a change here. So let's, yeah. Let's see, git signs. On stage, what was it? Reset hunk? No, stage hunk. I know I have a keybind for this. Hunk. Reset current hunk, stage current hunk. I wonder if that will just toggle it. Whoa. This we aren't going to do right now. The native is actually useful here. And I think necessary. So A. Let's see, tab C. This is DWARF. I'm gonna fix my keybind here for this. And this is DWARF line number program. We certainly want to add these changes in as well. So I'm about to sneeze. Okay. Yeah, we have a whole bunch of code added here. We're going to add all this in too. Stage punk. Let's see. And the last one. DWARF debug is just stage, stage, stage. Fix stage all changes to current state. Not stage. Commit. I need to be better at these commit there. Okay. Oh. Let's see. Sure. Set all, commit all changes. Need to fix bug. There we go. Okay. So now that we're there, if I run the line number program, see that I get this integer overflow in the parsing of the final compile unit, which is I believe the standard library. A lot of the standard library because, or stuff from the compiler, because it uses debug version 4. I can show that. Where's the header for this one? So here's debug 5, opcode, bam, and then it resets. Yeah, version 4. And, oh yeah, after reading all the files, I see the full header. Here it is, header, version 4, and it begins the opcode set. And so sets the file, then there's some padding, and then there's the instruction count 9, extend opcode 2, reader state, and we're at 3920, line padding, opcode, instruction count 0, extend opcode 0. So there's really right at the beginning an error. So if I run this and the offset is this 98 FD3, I just got to scroll down a bit. You can tell this is a version 4 because all of the header has all the names of the files here, and this all these green colors will show you where ASCII text is. So you can see a very common pattern is going to be 2E, which is a dot. So these are all ASCII letters. And then you'll see 7A, 69, 67, which is Zig. Zig, 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 Zig. Anyways, there we are. So the first first thing is 04. If we come down here, we do see set the file 04. And that sets the file to this number, 05, right? And then you get this 0, which is an extended opcode number 9, which is, or no, that's the opcode size. Sorry, opcode size is 9, and 2 is the set address, which makes sense. So set address, and then these next 8 bits here will set the address. So next opcode is going to be 3. Oh, see, there we go. That's a problem. 1, 2, 3, 4, 5, 6, 7, 8. It should have read all of these as 8. So there's a bug in our parsing of version 4. See, version 4 opcodes. Why is it only reading extended opcode set address header size if header size equals 8? So what does the adder size equal in the header? Adder size is null. Ah. Segment selector is null. It only read 4 bytes because of that. Read these first 4 bytes, 1, 2, 3, 4. And that's why these other 4 bytes aren't being read, even though it should be. It's a 64-bit system. Yeah, an optional U8. And I think it is null in version 4 because it doesn't exist. So let's open up the docs here. We go to line number program header, header length, scroll down to how it says you should handle this special opcode or this extended opcode. Standard. Extended. This is set address 2. Takes a single relocatable address operand and sets the size address on the target machine. So we need to know is the target machine, and I'm trying to remember where that information is. It's going to be in the header. Header size is optional. If version 5 address size, we take that. Segment selector size equals take easy one, take format. I think we need the elf target address size. Yeah. So what we need to do is do a target address size U8. And basically, instead of doing that, do target address size. Add a note here, note. Version 4 of DWARF does not specify this in the header. However, it does. It just, see, it uses the size of the given from the target. Uses the address size implied by the target. There we go. So now we need to fix the call sites here. That is in DWARF debug info. Elf dot IO reader. So read and compile unit, we get the unit header. Unit header have the address size? It does. So we should just get the address size from the unit. Unit dot addr size. Let's see, expected. Leave, we want then, yeah, line number, header. Here we're not reading the full units, we're just reading the debug line sections. Let's see. I don't remember if there's a format that tells you what the 64-bit format is. Version specifies required machine, specifies object file version, flags each size, member, elf header, the program header, section headers. Okay, class size, that's what it is. Or class, arch class. Okay, so we need arch class from the header. Yep. Defines architecture for this binary. It doesn't define architecture, defines size. This is 4-bit, 32-bit. Okay. Const header size equals if elf.header.arch class equals 32. What is it at? 32 bit 32 then 4 else 8. Okay. Expected IO file. That make them down to IO. Let's see, view hunk. Okay, let's see. Value with comp time only, comp time int depends on runtime control flow. We can fix that. That as let's see, 8 as 8. So let's rerun our debugger. That certainly made it to a different thing. Integers not fit in the destination type. Okay, that's good to know. That's part of our fix with the line number changes. So let's figure out where it happens. Current offset 1043. That we could say right here. 1010, so 1010. Okay. 0x1010. There it is. So get just a bunch of padding. 5. Opcode set column, set prologue end, set address. It's a little Indian, so we'll get see 11E9BA0. Yep, 11B9EA0. Okay. And then we're going to get the advanced line. What was the point that it failed at? 1043. So just right here is where it fails. Okay, let's just scroll through here. Copy 0x01. Then we get advanced line of minus F. So that should be, the line number is 2B7, so it should be 2A7, 2A8. That makes sense, yeah. Line advance 0x08, up advance 9, so address will move. And we get a set column, and then a line advance and op advance. Okay, here we come. Line advance 0. Okay, and then a set the column. And we're going to get a special opcode where we advance line by 2. That take us to 2A, C, D, E, E. Yep. Then we're going to negate statement. Oh yeah, that makes sense. Statement's now false. And this is the failing one, right? 1, 2, 3. No, next one's failing. Minus 2AE should be 0. And add the program counter. And that's where it fails. Adding 0x8 to the program counter. Interesting. And special opcode 255. Oh, advanced program counter. Yeah. There it is. Advanced opcode takes a single unsigned LEB operand and as operation is, and modifies the address and op index registers as specified in section, but does not modify the line. Okay, so that's the problem. Let's do that. Op index. Yeah, sorry. Okay. So the problem here is in this advanced opcode, so extended opcode. There's is it? Oh, it's in standard opcode. Standard opcode is advanced program counter. LNS const add program counter. Oh. Const add program takes no operator. It advances the address and op index registers by incrementing the corresponding to special opcode 255. Okay, so it's add special opcode right here. So instead of doing this, what we need to do is do decode special opcode 255 header. If that's what it needs. Yep. Decoded. Const decoded, and then what we need to do is basically go to here and copy these two lines. And instead of being deltas, it should be decoded, coded. Coded. Okay. I need to make this so I can like split it on lines. I don't like how long those lines are. You figure out how to do that with the. I think if I do that. Yeah. All right, so we take the address, we take the min instruction length. Yep, that should fix our problems. Integer does not fit in destination type. Still doesn't like that. Did I copy too much over? Oh, I didn't delete the right line. Okay, nice. Nice. That worked. It still errors out the process not found. We'll get to there. And we're leaking a whole bunch of memory. Need to fix that. That's good to know. Okay. Let's commit this. How do I keep making so many changes everywhere? Okay. Yeah, I added some comments here. We'll add this Alt-G-A. Okay. Then let's DB. What is the next hunk one? Let's see. Next hunk. Hunk. Current hunk stage move to it's This is the only change. Okay. Yes, this one. And we want to stage this. Yes. And okay, so we got that. So this is first, let's see, fix. This is, let's see, add, no, yeah, set address size based off target size. The line number program depends on an address size that is either set in the line number programmer headline number program header, or is taken from the target program address size. Here we set it to the unit dot adder size and then replace it if the DWARF version is 5 with what is in the line number program header. This fixes an issue where the line number did not read enough bytes for the address size. Okay. Okay, and then let's stage this one. Oh, let's fix that too. This is the fix here, right? Here we go. Yeah, it's already staged. That change is, oh yes. Fix, stay, only advance, see. Add program counter, let's see. Fix dance address and op index for add PC. Okay. Only the address and op index should advance for the add PC operation. Previously, this would previously this would advance the program to a state that would advance using the same function that advances a standard opcode, or no, a special opcode, but that also advances a line number, which should not be done here. Okay. Okay. So now let's fix these memory leaks here. Right here. Memory address 0x7FBFE1400800 leaked. That is our multi-array list. Right here. We're appending to data at 24. So where does data come from? Pair defer for sure. We will do this is data.dinit. Okay, line matrix. Hey, sweetheart, a second. Hey, maybe you should not be here. Yeah. No. All right. Can you hear me now? Sorry about that interruption. And I'm sorry, I've got the work isn't working for me right now. It's detached. But I do see the comments over here. So let me focus on these. Sorry, the sound wasn't working earlier. Yeah, I don't know how far along you'd say the project is. I'm getting there. We're getting line number finding around done. We're working on that. But it's been a lot of fun. I am really disappointed that work is not working. Let me see if I can work what's it? reconnect with. All right, there it is. It's there. For some reason, it did not connect originally. But yeah, is it already in a usable state? No, it is not in a usable state. Though, well, no, it's not in a usable state at all. This here is a line number program debugger. It's a crashed version of it. And this is kind of cool. Tool I built to help debug my programming the debugger. But yeah, so we were gonna fix these memory leaks. That's right. That's what I was working on. Sorry. Yep. Where was that at? It was leak of the line number matrix. That's right. And compile units, we attach that there. So really the compile units needs to where we, yeah, when we deal with the compile units, we clean everything up after that. So I think that's in the main should be here. Debug info. Get info from ELF returns the debug info. Debug info deinit. Okay. Yeah, here we are. Compile units. Deinit. There we go. So here, allocator dot free line matrix, or no, we need to deinit it. Allocator line matrix cu.line matrix dot see deinit. Compile, let's see. What was it? Allocator. Okay. And there's no function on line matrix for deinit. Well, there will be now. Pub fn deinit. And it should take in line matrix. Right? Yep. And it's taken allocator, which is in and it should return void. And do I not have allocator in this namespace? I do not. Const allocator equals standard.mem.allocator. And what do we have here? we want to dinit the line number. So lm dot data dot d init. Oh yeah, we need a pointer to here we go. Okay. All right. So let's see if that clears up. Yep, that clears up all our memory leaks. Still a problem with the process not being found. So let's do that. But first, let's commit the memory leak. CSSCC fix fix memory leak. Of line matrix. Okay. All right. Okay. So our debugger is it's finding, it's starting process not found. So I'm having a hard time attaching to the process. Let's do that. I think it's tracer. Yeah. For some reason, tracer is really old code, is not finding when I try to set the breakpoint. Is that what it is? I'm trying to call ptrace on the continue function. There it is. Continue execution until next breakpoint or process exit. You have the PID. Ignore. So right here, it doesn't like, right? So I'm starting trace registers. Oh, I wonder if it's just a problem with the way I've got this set. So it's been a while since I've touched the debugger code, because right now the debugger is hard coded to just run through the program. Doesn't actually take input. Get line addresses. I actually want to see if it gets the line address here. I don't think this is done. So let's see. Const log.debug address from line from. Oh, I've been working on this for a long time. I took a break for a while and worked on something else because I got stuck. I just didn't understand things enough. But now I'm back at it, and my my goal this year was that by the end of the year I should have it in a usable state that I could give like a beta version out. A beta out for like a limited group of people to start testing and using. but we'll see. We'll see how it's going. Let's see. We'll do this const file. No. Yeah, I'd love to let you're on Zigit, right? VMPol. I think I've seen you there. When I get to that point, I'll probably post a something on Zigit and then ask for people who want to be some bed testers. I've got a few on there that I think would be good to use it to test it. See my address from CS E is X. So let's see. We want file line no and address. Ooh, addresses. Okay. That's super slow. That's one thing is I want to make sure we get this. I'm probably slow because of all the printing I'm doing, but I'd like to make this a lot faster eventually, the parsing. So I feel like I'm gonna have to rewrite everything. Oh, it doesn't like this. And that's why, because this doesn't actually do anything. Okay, that doesn't do anything. That's frustrating. We'll come back to that because I do want to figure out why we're getting this can't find process. Error. I think if I walk through this, we search the path, get the target file. So the target, yeah, we're opening the target to get the debug information out. Then we start the trace on the child PID. We then try to do this. This doesn't do anything. We then wait. So I wonder if I got rid of this. This wait here. Okay, that didn't do it. So I gotta pull up key trace. Trace continue. Restart a stop trace process. If data is non-zero, it is interpreted as the number of a signal to be delivered to the tracee. Otherwise, no signal is delivered. Thus, for example, the tracer can control whether a signal sent to the tracee is delivered or not. address is ignored. See, I'm waiting the PID here. Error process not found. Weird that I'm getting that error. Is that from ptrace? Or from POSIX, Zig? But the POSIX namespace was gone. Standard POSIX. Local bin Zig 8616 tdlib vim. Okay, and we want to find POSIX. Standard POSIX Zig, yeah. One 522. See SRCH. SRCH. Tracer cannot assume that the ptrace stop tracee exists. There are many scenarios where the tracee may die while stopped, such as a kill. Therefore, the tracee must be prepared to handle an ESRCH error, an error search error, on any ptrace operation. Unfortunately, the same error is returned if the tracee exists but is not ptrace stopped for commands which require stop tracee, or if it is not traced by the process which issued the ptrace call. The ptracer needs to keep track of the stopped running state of the tracee. Interpret eSearch as tracee died unexpectedly only if it knows that the tracee has been observed to interpret stop. Guarantee that wait PID wait no hang will reliably report tracee's death status if a ptrace operation returns eSearch. Okay. In other words, tracee may be not yet fully dead, but already refusing ptrace operations. So let's take a look at why. By the way, going back to where we were here. Why am I not getting a ptrace error? Oh, it's on continue. Oh, yeah. Okay. Duh, I'm looking in the wrong spot. Continue should give a ptrace error. So we need probably tracer to keep track of Tracy state. Let's do that should be a is do this and do const trace state num stopped and can't remember what the states are actually named. Stopped. Oh, we should probably do exited too. Yeah. Stop exited running. Exited. And we'll do, we won't have a default here. Actually, we'll do dot stopped. Because should assume that it is stopped when we start. V and Paul, are you working on a project yourself with Zig? Unfortunately, no. I'm sorry. Well, it's nice to have you around. You just interested in Zig or uh, trying to work it into work? Let's see, where was I going for? Oh yeah. So run the debugger, run the target. So I want to make sure the target trace me. So here we issue the trace me call. Yeah, indicates that this process is to be traced by its parent. This process probably shouldn't make its operation that the parent isn't expecting to trace it. ptrace trace me operation is used only by the tracee. Running operations are used only by the tracer. And the following operation. Nice. Yeah. Still having some personal projects in Zig. That's good because when you're using the debugger to test it, it's nice to have a project to be working on with it. Do you use debuggers generally, or I'm just curious? A lot of people don't, and so ptrace attach, ptrace sees, ptrace interrupt. So I wonder if trace system, a tracee first needs to attach to the tracer, or it needs to be attached to the tracer. Attachment substitute command for thread and multi-threaded process. The process can initiate a trace by calling fork and having the resulting child do a trace me, followed typically by an exec VE. Alternatively, one process may commence tracing another process using ptrace attach or ptrace seize. While being traced, the tracee will stop each time a signal is delivered, even if the signal is being ignored. An exception for Zig kill, which has its usual effect. The tracer will be notified as its next call. So wait PID. Indicates the cause of the stop in the tracee. While the tracee is stopped, the tracer can use various ptrace operations. The tracer will then causes the tracee to continue, or optionally ignoring the delivered signal. Optionally ignoring the delivery signal, or even delivering a different signal instead. If ptrace o trace exec option then when we do this, ptrace trace me, and then we exec. My understanding is that it should put it into a state where it is ready to be traced. Let's see. Tracer will be notified. Yeah, I like debuggers. I'm not the best at using them sometimes, but I think they're very helpful. Which is why I want to build one for Zig. And it's just a fun project to work on. One of the way. Trying to figure out the signal delivery stop. Oh man. Go mod or cargo. Yeah, I mean, yeah, that could be very nice. There's obviously there's Zig fetch, but it's not as nice or as, I don't know, easy to use as cargo or go mod for sure. Let's see. Why? So we run the target, refork. If it couldn't fork, we catch it. Otherwise, we run the target and run the debugger. Warning is reminded, don't, yeah, I know, don't leave loop C. Unable to set the trace. I wonder if the tracy actually never stuck. No, it does. It does run because this runs. And that means that the fork and exec e do run. Which means we get to this exec e part here, run the target. And here what we do is we wait, we read the registers. It's the continue that's failing, right? Wait status 0. And wait. Okay, meaning wait for any child. Yep. And then if it returns, what does it return? Wait, on success returns the process ID of the terminated child. On failure, -1. Wait, PID on success returns the process ID of the child that has changed. If Wait, no, hang was specified and one or more children specified by PID. We have not yet changed state, then 0 is returned. On failure, -1 is returned. Oh, course weight status 0. I logged at the wrong spot. Okay. $14.07. And then so switch turn code. Oh. What? I'm really confused. Oh yeah, okay. Yep, no, I'm getting this. Return code. That's not right. Current code should not be. Return view size. Oh wait, it does. It returns. Yeah, it should. It should return address. Okay, rate PID on success return Linux node in the Linux kernel. See notes. Yeah, we have a bunch of statuses. So that wait PID takes the PID, a status, and options. That's what we're doing. We're making the system call essentially here. It's the raw system call. Get the status. We get this. Now, return code. If return code, okay, yeah, okay. If return code is less than 1, then we get the error. Otherwise, we give success. Okay. Log.debug file. I'm curious to make sure that matches. So okay, so those numbers match. Then wait if stopped. Return failed to stop child. Status and FF, so we only look at the last 2 bytes. 7F. If stopped. Returns true if the child process was stopped by delivery of a signal. This is possible only if all was dying. 1 traced. Or when the child is being traced. Okay. POSIX. So UXFF. Yeah, I just lifted that from libc. So 7F, yep. Okay, so it is 7F. So we got wait if stopped. Okay, so that's all working correctly. So let's go back to the main. Wait, we read registers. We get the Tracy register, and we do continue. And we get an unable to find it. That's what's strange to me. One, two, three, four. See the system call level, the ptrace peak text, ptrace peak data, and ptrace peak user operations have different API. Tracy parent continues to be the tracer, even if that tracer calls exec VE. User area are quite operation system architecture specific. Offset supplied and data return might not entirely match the definition of struct user. C's attach. Very strange this doesn't stop the system. Like it says it's waiting. Or it says it's stopped. Unless that's changed. Stop. See if we can find that in here. If stopped. Wait if stopped. All right, let's try this. No, this is gonna be oops, Linux. Let's see. Standard.linux. os.linux.w. Yep. Stopped. Okay. See if this works differently. Still doesn't. Wait. It truncate the last 4 bytes. Shift it over 8. Doesn't make any sense. What do I think about the new IO and Zig? I don't know. I have not really played with it a lot. A lot of the upgrade from 6 or upgrade from 15.2 to 0.16 was actually really easy for me. All I really had to do was add IO to a few file reading things, and it wasn't that bad. It was not nearly as bad as or nearly as much work as the upgrade from 14 to 15 with the writer gate and readers and writers. And I think the reader and writer interface is pretty nice. But I haven't played around with IO a lot, so I don't know if I can actually judge it properly. Return is great. Oh. Interesting, is greater than 0x7ff. So if we think it's a bool, so if it's not greater than that, then it's stopped. Saying we get the last 2 bytes, okay, and we multiply in an overflow manner by 0x10001 and shift it over 8. and truncate it to a U16. And if it's bigger than that, so basically if it's got the high order bit set, then it's not stopped after you do all those transformations. Yeah, I would like to do, I should do one about IO. I'll need to play around with it and get better at it. I think that would be a couple videos probably, but I've never really been into async. I don't not used it a whole lot, and so I'll have to figure out how to get a good video for that. That's a good idea. Okay. Well, I know it's stopping. I keep getting sidetracked here. It's the continue. It's just weird that it's not. If it's stopped, and I call the registers, read registers. This ptrace continue. Something's wrong with it. I'll have to look at that. I'm also going to have to stop streaming for today because it is time for me to eat some lunch. And yeah, but thank you for watching. I'll see y'all next time.